we are doing section 5.1, new chapter, and we're at learning target 1, which is solving linear systems by graphing. So the learning target is I can solve a system of equations by graphing. I know that the point of intersection is the solution for both equations. So going back, we had done a 4.4, which we graphed in slope-intercept form. And so this would be what we are doing. However, now we're going to do systems, which a key point for a system is you have two or more linear equations. The solution is actually a point that when you graph both of them, both lines intersect, so they hit at one point. And then the solution is also going to be true. If I give you a point, you plug in an x and y, you should be able to tell me if they match. So that's going to be the first one. We're going to look at part 1 in the notes, and that is if I give you an ordered pair, you can tell whether or not it's a solution to a system. And again, a system is just two or more equations. So there's two equations, and our slope-intercept form is the y equals mx plus b. We like it in that form when we're doing systems. It makes it easier to graph. Again, remember when we do our graphing, we put our first point on the b, and it's always 0, comma b, and we put our first point here. And then we use our slope, our m, and we rise over run. We count. So that's just going back to, again, in your 4.4 notes or any of the practice that you did, that's how we graph in slope-intercept form. So then when I give you the solution, this is just algebra where you're plugging in numbers. This is the x, comma, y. So for each equation, I'm going to do this top one first. I'm going to plug in the y value and the x value. So I'm going to end up with -4 equals -4 minus 0. All I did was plug in my y and I plugged in my x right into this equation. I'm just plugging them in. So then I get, I'm going to use my calculator, -4 equals, and then -4 minus 0 is -4. So if this is true, -4 equals -4, I'm going to put a check mark. That means it's that this ordered pair right here is a solution to one of the equations. I have to check both because it's a system. So I'm going to do the second equation underneath. The second equation is x minus 5 times y equals 20. So I'm just, again, I'm plugging in my ordered pair, my x and my y. I'm going to plug them in here. So I have x, which is 0, minus my 5 times y, which is -4. And then I'm going to put equals 20. All I did was plug in my x and y values into that equation, the second one, and then I'm going to do the math. In my calculator, I'm just typing all this in, one long string of numbers. 0 minus 5, and that parenthesis means times -4. So then I end up with, your calculator should tell you 20. So does, and I'm going to bring down the rest. 20 equals 20. Is that true? If it's true, we put a check mark. That's yes. So since both of them are true, that means that yes, 0, comma, -4, that ordered pair is a solution to the system. It has to be true for both in order to be a solution. So you will go for this second one. This is your x and your y. You're going to do the same thing. You're going to plug in your x into each equation and your y and check to see if these work. So I'll do this here. So my x, I'm going to use the first equation here in green. So I'm going to have 3, that's x, plus 2 times y. So 2 times my y is also 3. And then equals 9. All I did was plug these values into my equation. And I'm going to use my calculator, again, just one big long string of numbers and operations. 3 plus 2 times 3, 9 equals 9. So it's 9 over here, and then we know it's equals 9. So this first one does check out. It's correct. It's a solution for the first one. But to see if it's a solution for the system, I have to do the work for the second one too. So again, I'm going to do x and y, and I'm going to plug it into the second equation. So it says 4 times x, so 4 times my x is 3, and then minus y, which is 3, y is 3, equals 15. So let's see, if we put that in, it should be 12 minus 3, so I get 9 equals 15. That is not true. So what that means is this is a no. It's not a solution because both of these are not true. It has to be true for both equations. So that's our first part of the learning target. I call it part 1. If I give you an ordered pair, can you plug in numbers and tell me, is that solution point is it part of the system? So let's go to part 2. So looking at part 2, I have my graphing in slope-intercept form. So here are the steps. Again, we talked about these steps. There's 3 steps when we graph. So the first thing is we graph both equations. We need to make sure that they're in slope-intercept form, which is the y equals mx plus b. And then we're going to estimate the coordinates of the point of intersection. We're going to see where they meet. And we're going to find that x comma y, and we're going to tell us. And then we're going to just check the coordinates to make sure. So just going back, again, we talked about when you graph in slope-intercept form. Right here, you put your first point on the y-axis. And then we use our slope. So this is our second thing. We count rise over run. If your slope is not a fraction, if it's a whole number, you need to put it over 1 because, again, we're going to be counting rise over run. So let's look at this first one. And equation 1, I'm going to put 1 up here, and then I'm going to put it in green. We just want to look at what's my slope or my m. My slope is actually 4. So I'm going to write it as a fraction. It's 4 over 1. When I go to graph this, I'm either going to go up 4 and right 4, or I can go the other way too. I can go down 4 and left 4. I can go front and backwards on the line. When I look at the second one, my b is a positive 4. So remember, we write the b as 0, 4. So I'm going to graph this first line. I put my point on 0, 4. It's 1, 2, 3. It goes right here. My first point is always on the y-axis, always on the b. I start here. And then I use my slope to rise over run. So if I go up 4 and over 1, I'm going to be off the graph. So I'm actually going to go, just flip it around, and I'm going to go down and left, just because that would be the other way on the line. We can always go both ways on the line. So if I go down 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. And then I'm going to make my line. That is graphing in slope-intercept form. We've already done this in 4.4. So we should know how to graph one line. With the system, we graph 2 of them, and we see where they meet. That's called the solution to the system. So let's look at, let's look at the second equation. Okay, I'm going to make that one blue, and I'm just call that number 2, equation 2. My slope is here. It's negative 3 over 2. And remember, I'm going to keep the negative on the top. That means I'll go down and right. And then my b, if I look at that, my b is this negative 7. This is where I start. I write it as 0, negative 7. So from here, I'm going to put my first point on 0, negative 7, which is right here. okay? And then I'm going to rise and run. But if I were to go down 3 and right 2, I'd be off the graph. So remember, I can always do the opposite. I can go up 3, but if I do the opposite on the top, I have to do the opposite on the bottom. It's just going the other way on the line. So instead of down and right, I go up and left. So I'm going to go up 3, 1, 2, 3, and over 2. I end up right here. Up 3, 1, 2, 3, over 2. I already knew once I did one of the points, the second one, I knew where they were going to hit. So I don't really need to keep going. I just make the lines. This is the solution. So I have to figure out what is this point. So just like you find an ordered pair. So I'm going to go over and check. I go over first for the ordered pair, remember? This goes left and right and up and down when I find an ordered pair. So this point where they meet, that's the solution. So it's actually -2, -4. And that is how you graph a system. I just also want to remind you, when you're doing a system, if there's nothing in front of the x, remember, so for this next one that you're going to do, you put a 1 in front of there. And then to make it a fraction, it's 1 over 1. But I'm going to have you do the rest of the graphing on your own, and I'm going to do a separate video for part 3. But part 1 and 2, you should be able to then test if a point is a solution. And part 2, you should be able to do, again, you're graphing in slope-intercept form, and you're graphing a system, which just means 2 separate equations, and you're telling me the ordered pair where they meet. That's the solution.